Hi, I'm Jerry Ko. I'm the Group Program Manager of the Human Interaction Platform team in Windows. In this video, I'm going to show you some examples of how hardware can impact the touch user experience. Let's talk about tap. It is one of the core touch interactions. A tap helps the user activate an app and plays a huge part in general navigation. It is also the primary interaction when you use the soft keyboard. In this example, the user is typing on the keyboard at a relatively slow rate, and attempting to type, the quick brown fox jumps over the lazy dog. What you see here is that the taps on the keyboard are not being picked up correctly, and the results on the screen look like a mess. This happens due to a couple of reasons. Some touch hardware just doesn't respond fast enough to pick up the individual taps on the keyboard. Some of them also can't detect taps accurately, and it results in these mistakes. If you start typing faster, touchscreens which only support 2 fingers start to ignore some of these taps. This is not a good experience for the user. Swipe to select is a lightweight gesture for users to select tiles. On certain hardware, this lightweight gesture is much harder to pull off. In this example, the swipe is being confused as a pan or drag. The user ends up accidentally rearranging their tiles when they want to select one. On hardware that meets our requirements, the swipe to select is easy, lightweight, and fast. In this example, you can easily swipe to select multiple tiles without it accidentally panning or dragging. Good hardware also allows us to build much more tolerance in handling swipes. As you can see here, I'm not swiping directly downwards, but the system still recognizes it correctly. Swipe from the edge is a very important gesture in Windows 8. It allows you to get quick access to the system charms or switch between apps quickly. On hardware that does not meet our requirements, swipe from the edge can be difficult. In this example, I'm trying very hard to swipe. However, it's constantly failing. The system sees these edge swipes as pans. This is due to a raised bezel on this PC, as well as the lack of touch sensitivity on the edges of the screen. On hardware that's designed correctly and meets our requirements, the swipe from the edge is effortless and quick. It should respond to your swipes instantly and allow you quick access to the system charms. Let's look at rotation. On certain hardware, rotation can be an unpredictable task. When you start rotating in the Photos app, there will be instances where your fingers on this screen are detected as moving in the opposite direction. This is unexpected behavior that can ruin a great user experience. On good hardware, this experience is totally predictable. The photo rotates or zoomed exactly how you expect it to. This is the experience we're after in Windows 8, where everything is predictable and confident. Rearranging tiles is a common activity on the start screen. On some hardware, rearranging tiles using 2 hands can cause issues. In this example, I'm using one hand to drag a tile and another hand to pan the screen. On this hardware, you can see that touch is not registering correctly. The tiles have floated off my fingers. This is certainly not a good experience, and if it happens often, can hurt the confidence in using this PC. On hardware that tracks the finger accurately, the user can confidently pan while having a tile selected. You can also place the tile accurately wherever you want. Successful apps work consistently on every form factor, every time. The user needs to adapt easily, and the developer should not need to develop for any hardware variances. Touch performance plays a big part in consistent experiences. In gaming, it's important that touch responds accurately and quickly. In this example, the paddles defending the goalpost can barely keep up with the fingers. It becomes impossible to play this game with any success on this hardware. Consistency is also important when designing game mechanics. In this example, the game plays very differently on different hardware. On a machine which only has 2-finger support, the paddle cannot be resized, as you need 1 finger for each paddle on each side. In the original design of the game, the paddle can actually be resized and has special behaviors to make the game more interesting. It was designed for 4 fingers. We do not want developers to have to rethink their app to handle limitations. That is why we are requiring 5 or more finger support in all new Windows 8 PCs. Here is another example. The popular piano app attempts to mimic the real world. If you want to play chords on this piano, you can't, as the touchscreen supports only 2 fingers. On this machine, you can't do that. You can only play the melody. When you try to play the chord, nothing registers as the system doesn't know what to do with all the fingers that you're placing on the screen, and it stops responding. I'll show you an example here. This application supports 2 fingers, and thus it works very well with 2 fingers. But once you put on the 3rd finger to try and play a chord, it goes crazy. Whoa. On hardware that supports our requirements, the experience is much better. It's very confident 2-finger playing here. And if I want to play a chord, I can just add another finger. And I'll be able to do that. I can even start playing melodies now. I hope these examples give you an idea of how hardware can impact the touch user experience. We are working with our hardware partners to ensure that new Windows 8 PCs will provide the quality and confidence you should expect. Thank you for watching this video.